before I start talking about this, this is a new series that's of like Skillshare meetups that I've been talking about with a few people here, like Matthew and John, and also Georgios. And we thought it'd be cool to have like these meetups where anybody can come in and present something that they think they do well, and kind of just show everybody else how they do it, and just to kind of like do a Skillshare. I think it's a good idea. I think a lot of us have worked on a lot of projects, and you always learn things along the way. And a lot of the times you're like, I wish I knew how to do this already. So it's a nice way to kind of like skip the problems and get to the point where you know what you're doing. I know, Alexander, you already said like you had some topic ideas, so I think that's great. But yeah, I think and everything that you sent sounded good. A lot of stuff with nerfs and photogrammetry, which it's pretty interesting. Matt, I always look to you whenever people say stuff. I mean, I'm not just saying that. I mean it. I think it's very cool. Every time I try to play with nerfs, it always messes up because, like, I don't know, the coal map thing takes forever and I get tired. But yeah, so I think it'd be like, my hope is that like we do this super regularly, like maybe every 2 weeks or something, or like eventually down the line, like something like that, and that someone's always presenting something completely different. What I really think would be awesome is if 2 or 3 people present on the same thing, but everybody does things differently. And I think that could be cool to see everybody's point of view, because there's no right or wrong way to do things. It's just like something that works for you. So yeah, so that's my pitch, and hopefully more people will do it. I think we don't know when the next one will be, but I think we're going to figure that out September, and then yeah, so in September we'll do some other thing. And Alexander will still be here. Great, so he might be next. Okay, so the first thing I wanted to talk about was just Git, which is a version control system, and I'll explain what that is, and then Syncthing, which is just this tool for sharing files. And I wanted to talk about these first because they're like very basic things. It's probably going to be a little dry because it's just like, basics and showing you how to do stuff on a computer. But that being said, I think it's really important to, I think these two tools are really important. Every project I start, I set up Git and Syncthing right at the beginning, even if it's just a personal project, even if I'm just sketching something and I know I want to be able to kind of go back and forth with my thoughts, I just set up a Git repo. Once you know how to use it, and once you get really familiar with it and comfortable, it's super easy to set up. It takes like 30 seconds, and the power it gives you after is really good. So it's like it's just a useful thing to have. Has anybody here? Do y'all know how to use Git? You do already. Okay. Okay, so. Okay, so I mean, this might be, so then if you do, it might be a little bit boring because I kind of did this as a basic thing as people who don't know how to use it. And the reason for that is that I get on a lot of projects and I'm like, okay, we're going to set this up on Git. And a lot of people have no idea what I'm talking about, or they know how to do like one specific thing and nothing else. And then whenever there's problems, they don't really know how to deal with them. But anyway, that's me. Okay, so Git, I don't know what it stands for, if it stands for anything, but it's a version control system. And what that means is that basically you have a collection of files which are going to be your project, and using a system like this, you can make snapshots of what those files look like over time, and you can make as many snapshots as you want, and you can kind of just I guess like keep the progress of your project in a history. So as you work on your project and as you make updates, you can just say, okay, like save this point in time. Then you do some more work, save this point in time. You do some more work, save this point in time. And by doing that, you basically, you do a lot of things. One thing you do is you document the progress on your project. The other thing you do is you have a backup of everything you've done, and you can always go back and forth in your backup. And the last thing you do is if you collaborate with other people, it's very easy for you both to share this project or to like clone this project that you're in, and kind of work at the same time and both contribute to the same Git repository is what it's called. And it just helps you work in parallel with other people. So it's good both on an individual level and on a like collaborative level. So there's a few verbs and terms that are important in Git. And I think it's important to go through them to understand what they mean, because it makes a lot of sense. A lot of people, they don't really know what the words are, and they just keep saying, oh, I'm going to fork the thing. And you're like, what are you saying? That doesn't make sense. So it's kind of like important to know what all the words mean. So this directory, this project that we're talking about, it's usually going to be called a repository. And a repository is essentially a folder and subfolders and a bunch of files in them. Everything that's in your repository is able to be tracked for changes. And what are changes? Changes can be adding a file, it can be deleting a file, it can be renaming a file, and it can be actually editing a file, so changing the contents of the file. So all of these things are tracked by Git and can be saved and reverted by Git. There's different version control systems also. It's not, Git is not the only one, but one thing Git does that's sort of important is it doesn't track folders, it only tracks files. So if you have an empty folder, it's not gonna acknowledge it unless you put something in it. And I don't know why it does that, but it's something to keep in mind. So usually what people will do if they have an empty folder, but they want to keep it there as a placeholder, they'll just put a dummy file in there. Usually you call it .git keep, like git keep, and that'll just keep the folder. And that's kind of a convention that people know. That means keep this folder there. You don't need to put anything in it. And then a set of saved changes, these things I was talking about, is called a commit. So a commit is, I was thinking about this when I was writing these, and I was thinking, oh, it's kind of like, if you're into crypto, it's kind of like crypto. You can think of it as like a ledger, and then every single commit is a transaction. And the transaction has an author, it has a date when it happened, and it has an ID. And in this screenshot here, the idea is like this hexadecimal number here. This thing that looks like a date is the date. This thing that looks like it's a person's name is the person's name. Can you see well? Yeah, okay. And that's it. So whenever this thing I was talking about before, I'm like, okay, you save a snapshot. That snapshot is called a commit. And the way it works is that these are saved in order. So whenever I create a snapshot and then I create another one, the next one goes on top of the first one. And that order has to be maintained in the repository. You can't really shuffle these around when you move the project over. So let's look at the different states that a file can have. So first, when you work in this project, you have a bunch of things you changed, and those are just called unstaged changes. So that's on your computer. You haven't done anything yet. You've just like created files, written some stuff into them, and that's it. Then when you're ready to save those, the first step you do is you stage them. So those aren't in the snapshot yet. You're just saying these files here that I'm selecting, I'm going to get ready to save into a commit. And the reason why you have this step is that you might have a lot of changes, but only want to commit some of them. Or you might want to make like a few commits to like kind of organize your changes. So that's why there's this intermediary step. So first thing you do is you stage your things, and then after that, you will commit them. The cool thing with staging is you don't just need to stage an entire file. You can actually go in some files and only stage parts of it. So sometimes if I forget to make changes and stuff, and then I have a file that has like 2 different pieces of code that I've changed, I might be like, okay, well, I can actually only stage like the top half of this file and then make a commit for that and then stage the bottom half. And that way it stays, if those 2 things are different features, it makes sense to do something like that. And then finally, after you've done the staging, you commit the staged files. And the commit is where you're actually entering a new entry in that ledger. So this is where this gets saved for eternity and it can't change at that point. Whenever you do a commit, I was saying before, you have an ID, you have a name, you have a date, but then you also have a message, which is required. You can't have no message. And the reason for that is that every commit should have a description. So you should kind of say, what is the point of this commit? What did you do? Usually a good convention for your commit message is that it's like an action in the present tense. So you're saying, what does this commit do? This adds the password to the file, or moves the garbage over here, like something like that. So let's start with a demo. So I guess Git is a piece of software. It's a system. And at its bare version of it, it's like a command line tool. So you open a command prompt and you start typing in commands, and everything that I just mentioned you can do through commands, and it's kind of complicated and annoying. A lot of people use Git just through the command line. I don't understand why, but a lot of people are like, oh, I'm hardcore, I only use the command line, I don't use a GUI or anything like that. And what I realized through my years of working with these people is that a lot of people who use the command line don't really know a lot of the features that Git has. They only know how to do specific things, and they kind of stick to that. And I find that using a GUI makes it really a lot simpler to understand what's going on in the entire network, not just the current state of your project. And also it lets you not have to remember like archaic like words that don't make sense. You just kind of click buttons, and it makes it a lot more powerful. So there's a lot of different tools out there you can use. Like there's a lot of GUIs which basically like hook into Git and have a visual representation of them. I'm just going to show you one called Fork. So it's git-fork.com is the website where you can download it. I like this one a lot because I think it has the best interface out of everything that I've tried. It's also freeware or shareware, I guess. So you can use it for free as long as you want. And then if you feel generous, you can give the author $50 for a lifetime license, which I think is a great idea. It's actually one person who writes it, who lives somewhere in Eastern Europe. He does a great job. So this is the one I like to use. However, if there's other GUIs you like or other tools you like, they do a lot of the same thing. It's just the way that stuff is visually represented is different. The only one I would suggest against using is the official GitHub app. And the only reason for that is that it does a lot of stuff behind the scenes. And I think like this one is a nice middle ground between like making things easy and always understanding what you're doing. And I feel like with GitHub, you don't always understand what you're doing because it does a lot of steps without telling you. And you kind of need to understand what you're doing because when things break, you need to be able to retrace your steps. So yeah, Git fork, that's a good one. Okay, so let's create a project. So creating a project is super easy. First, what you do is you would create a folder somewhere on your computer. Call it ONX stuff. Now, if you have Git fork installed, you can just go to File, Init New Repository. You find it. And that's it. And what this actually does is it calls this function called git init, which you don't really need to know, but what it puts this little .git folder, which is an invisible folder in your project, and then it puts a bunch of stuff in here that you really don't need to worry about. But that's what's happening. So now we have an empty project. Remember I was talking about unstaged changes, like your local working copy. So that stuff's going to live up here where it says local changes, and everything else we'll see later. So now there's nothing in here because we haven't done anything yet. So let's open this project in a text editor. And also I should note that a project can be anything you want. It's really just a directory on your computer. So it could be a Unity project. It could be a bunch of text files. It could be a website. It could be like a bunch of photos in a gallery if you wanted to, although that's not the best use of Git, but those are all things that you can put in there. It doesn't really matter what you put in here. So I'm going to create a new text file. I'm going to call it, I don't know, readme.md. So it's markdown. Yep, save it in here. So now markdown is a format for, it's like an easy way to format text without having to use funny tools. So if you write stuff in markdown, for example, if you put a hash before a title, it'll look like a title. This on the right is what it renders to. If you put two of these things, it makes a subtitle. If you put three of them, it makes an even smaller title. If you want to make bullets, you just put a star and say, I don't know, pepperoni. What else do you put on pizza? Cheese. What'd you say? I don't know, something was, I didn't hear what you said. I think you said gram with style. I don't know that. Anyway, so that's what Markdown is. You don't, but anyway. So I just, usually when I write notes, I use Markdown because I'm familiar with it and it's easy to write notes and format them. It is so, well, a lot of the Git hosting websites, if you put a file in README in Markdown on them, it'll automatically render it out properly. So that's why it's a good format in this case. So I created this file. Now, if I go back to fork here, you'll see that in local changes, there's a new number in parentheses, which says 1. So that means there's one change. And the changes, there's a file here. And if I click on the file, it shows me the contents of it, which I just added here. Also, there's a plus and a green icon on it, which means this is a new file. So let's go ahead and commit that. So first step is I'm going to stage it, which goes in the stage section here. And now to commit it, I just type in a message So I will say like initial commit add README file. And then I commit it. Ta-da! So now there's nothing going on here. There's no more local changes. There's no more unstaged changes. There's no more stage changes. There's nothing in my interface because there's nothing in my system that is not synced with my repository. If I go to all commits here, I actually see this like the first entry in my ledger here, which has my message, the author, which is me, the hash for it, and then the date that it happened. And then if you look down here, and it'll actually show you which files changed, like the different interface to it, the file tree, if there's like many different files, and so on and so forth. Let's say we want to make more changes. So I'm going to go here. I'm going to create a new file. I'm going to call this one, I don't know, ingredients.txt. And then, I don't know, let's do pepper. Oh, yeah, pepperoni, sure. Pepperoni, tomatoes, cukes, I don't know. Dough, cheese, anyway, whatever. Okay, so I did this, and then also I'm going to go back into README here, and because I have ingredients over here, I'll just say, look for ingredients in the other file. Okay, so what did I do here? I created a new file, and I also updated this file. And actually, I'm using Visual Studio Code, and I'm realizing now it also has its own little Git thing going on here. So it says that, I don't know what U, M is modified. I don't know what U is, but whatever. I guess it means new file. I don't know what the U stands for. So if you go back to Git fork now, you'll see that there's two changes. And then if you click on that, you'll see there's different icons. README is a file that exists already. So it's yellow, it just means it was edited. And then the green one here just means there's a new file, which is ingredients.txt. And then what's cool is in README, you can see a difference of the previous file and the new file. So the red stuff is the stuff that was removed, and the green stuff is the stuff that was added. So if you have a lot of changes, it's super useful to kind of get a glimpse of your changes here. If I make another change up here, the title is ONX piece. Thanks. So now I've made a change here, and I've made a change down here, but this and this and this is still the same. So if I save this and go back here, you'll see that like in my file, it's saying, okay, this is what your entire file looks like. You added these two lines here, you removed these three lines, and you added this line. So it keeps track of everything you're doing, and it kind of like shows you like in a nice visual interface what has changed. So now let's say I only want to commit the ingredients file. I would only pick this file here and stage it. The README changes are still unstaged. And then here I can just commit that. So say add new file for ingredients. And push that. And now if I go to my commits, I have a new commit here with only this change. I still have a local change left, which is this README that I updated. So now I can actually go and stage that. Actually, I can do this in 2 shots. So let's say I only want to stage the part on the bottom. So in fork, you can actually pick which chunk of changes you want to commit. And that's what I was saying before about partial files. Confusing.
Oh, starting to like different chunks, different files.
Yeah, it's usually, if you think about it in code, let's say like I work on 2 features at the same time, then I'll have like probably 2 functions in 2 separate parts of the file. And then I'll be like, oh shit, like I should have finished the first one and committed, and I forgot. Now I have everything. So I can either dump everything in one commit, but it's usually a good idea to try to separate your features as much as possible, because when you need to go back and play with history, you can actually like say, okay, only revert this commit, and that'll only change that one function. So it's a really good idea to kind of stay diligent about that. But obviously, like if you made a bunch of changes everywhere and the thing is just a mess, you have to kind of gauge, okay, is this worth my time to like go through line by line and see what I need or not, and make sure that the output is okay? Or should I just whatever, like heat it for this time and try not to make that again? But in this case, we'll just say like, okay, add note about new ingredients file. And now even though I committed this change, I still have another change in here. So now I'll stage that and say like add a title in the title section. And basically, like you can see, everything just gets stacked on top of one another. And as I go through these commits, I can see what changed here and what the state is of my repo every step of the way. So that's kind of the basics of it. So you stage, then you commit. You stage, you commit, and when you commit, you add a message. And commit is like the final like saving, and stage is kind of like getting everything ready before you push it. Does that make sense? Cool. So everything we've seen so far has been why hide this thing? I don't see anything in the chat. How do I move this thing up? More? Oh, where did you see that? Oh, this cool. Okay, great. Okay, cool. So everything we've seen so far was local. Like we haven't put anything on the internet yet. Everything is, that whole repository is in that folder on that computer. And if you're curious, you can kind of go in that .git folder and snoop around, and you'll see that as you make these changes, new things get added and removed, and so on and so forth. Like this, all of these things kind of change every time, but don't worry about that. When you do want to take this code and put it somewhere else, that's called pushing your code. And that other place where you put it is called a remote, because it's not local, it's remote. So just a note about remotes, like a lot of other version control systems also have this concept of local and remote. The difference with Git is that it's not centralized. So if you use Unreal, you probably use Perforce. If you also, for some reason, they still use Subversion, even though it's a really old system. Subversion is like a system that a lot of people use before Git. But essentially in those two systems and in many other systems, everything is kind of centralized. So you have all these clients and they all communicate with one like main like repo somewhere on the internet, and that's like the source of truth. That's where like all the information goes and comes from. By being decentralized, Git doesn't really have that model. You basically have a bunch of repos and you can connect them together if you want to, and you can also not connect them if you want to. And there's no like one like main repo that everybody reads and writes to. There's just like a repo you decide is your remote, and you decide you want to try to match. And if you find another repo you want to match instead, you can match this other one. Or if there's two you want to match, you can kind of connect to both of them and see what they're doing and bring in the changes from them. So it's a much more distributed approach to it. That doesn't mean that it's complete chaos. Usually what people do is they will choose one remote and be like, that's the main one, that's the source of truth, that's the one that we all like communicate with. But it's an option. It's not something that you have to do. And usually that like lead repository is called origin. So that's just kind of like where things start. There's also a couple of other words you'll see: upstream and downstream repositories. So upstream is something that you push to, and downstream, like let's say there's many sources. So an upstream one is one that's like your source of reference, and then a downstream one is one that uses you as a reference. So in this case, for example, 3 is downstream from 1, but upstream from 6. But anyway, is this confusing? Or okay, cool. And then, and like I was saying, many repositories on many machines can be synced. So you don't have to always sync to one machine. You can kind of sync to whatever you want. And that's where this becomes really interesting, because you can kind of make your own setups that work for you, depending on if you're in a basement with no internet or if you're in a place that has high-speed internet. Like that all kind of matters here. So the repository you work in is the local one. Anything else is remote. And the thing that's important is to sync up. All your commit history must match. So if I add commits and the repository that I want to refer to doesn't have my commits, I'm only going to be able to pull from there. If I push my commits, everything gets synced, and then I can pull from there. So the whole point is that like the histories match the entire time.
Does that think the other way around?
Yeah, first that's true. So usually you will pull first, fix everything on your end, and then push the result to make sure that all the changes go in at the same time and the same order. And yeah, it's kind of like that idea of the ledger. The only difference is with the ledger, I guess, is there's one ledger, and then here you can kind of like fudge it a bit, as long as at the end of the line, like everybody agrees that this is the new history. And then another thing that's interesting with Git is by default, every repository has the full history. So if you don't do anything special when you pull or when you create your repository, you'll have every single file of every single commit in history of the repo on your system. So that's really great when you think about backups, because if you want to back up a project, all you need to do is pull the project, and you know you have everything that's ever been written about that project forever. You don't have to do anything special. Compare that to Subversion of Perforce again, where when you do a pull or something, you only pull whatever files are necessary to run the newest version, and everything else stays on the server. So if you lose the connection to the server and you need to go back or look at something from before, you can't do that. So Git is kind of special in that way. The bad side of that is that you get massive repos. If you have projects that have been like out for a long time that had a lot of changes, then you might have a massive repo for like something that the newest version is really small. But there's ways to prune it, and there's ways to only keep the history and all that. So it's more of a feature than anything else. And as I was saying, so the verb pull means you pull stuff down from a remote, and the verb push means you push your commits to a remote. So just to a different repository. Pull and push. So in our last example, where we were doing like staging, then committing, the next step after that is to push to a remote. And that means that all the files you have with all their history will go get cloned somewhere else. Okay, let's try it. So once again, yeah, yesterday I went in and added like little images to you. All of my things was like, shit, this is like way too dry. There's too much text. I need to add some images. So for hosting, you have many options. Like I was saying, you can kind of like host this on your own server. You can even just have a second folder on a hard drive that's like on an external hard drive that's your remotes. You can host it on Amazon. You can do all sorts of things, but the most popular ones are GitHub and GitLab. So a lot of people think that Git and GitHub is the same thing, but it's not. GitHub uses Git. So Git is the system, and GitHub is just a place that hosts repositories and also has all these like really cool features around them. So if you don't have a GitHub account, you make one. And then once you have one, you can make an unlimited number of public repositories, which means that anybody can access them and see the code. It doesn't mean everybody can write to them, but everybody can see them. And then for private repositories, they changed the rules. I forgot what it is, but you also have like a pretty generous amount of private repositories you can make on the free account. But I think it's like when your repositories get big, they probably have a size limit or something like that, where you kind of have to give them money when you start using a lot of server space. Okay, so let's say you made an account. You say, I want to create a new repository. And then, so if you have organizations and stuff, you can kind of change where this thing is going to live. So I have like a few different clouds, a few different organizations I'm part of here. And then I'm going to call this ONX, what did I call it? Stuff. And you can call this whatever you want. It doesn't matter. Now, the important thing here is if you've already started the project on your local computer, remember histories have to match. So you need to make sure that this one stays empty. You don't want to start, you don't want to start a remote repository with stuff in it. And because if you put stuff in it that gets committed, then that's not going to match your first commit. And right off the bat, you will have a conflict because it'll have history that you won't have. Okay, so what that means essentially is this section here where they're like, hey, you want us to put a README file in there? You want us to put a git ignore? You want us to throw a license in? You should not do that. Unless you want to start from GitHub and then pull those changes. But if you've already got something local, then you want to make this as clean as possible. That's fine, yeah. Okay, so once you have a repository, it'll have a URL that you can use to link to it. There's two types of URLs. There's SSH and HTTPS. Basically, in GitHub, the nice thing about it is depending on if your stuff is set up properly or not, it'll put the right option for you. So if you set up an SSH key, which means you typed a bunch of commands in your computer, then it spit out a file, and you uploaded that file to Git, and then whatever to GitHub, and then it like recognized the file, then you can use SSH. If you didn't do that, you'll use HTTPS. They're both secure. The main difference is HTTPS will ask you for your password, the GitHub password to put every time you want to upload stuff. And SSH won't, because it uses a key, like a secret file on your computer. they're both fine. There's no difference. So I'm going to copy this URL. Then I'm going to go back to my repository here. And under remotes here, I can right click on that, say add new remote. And then Git fork will automatically fill in the details, but you can call this whatever you want. So remember I was saying origin is usually what you call your reference point. That's what it called it. But if I wanted to call this GitHub, I could. And the repository URL, I just pasted from my clipboard, but this also you can write whatever you want. And that's it. Then you do add new remote, and this thing gets added. And now you see that I have a new remote here called origin. And there's nothing in it. So if I pull, which means I get all the changes from the server, nothing should change because there's nothing on there. And there actually aren't even any branches on there, so there's nothing to pull. There's nothing going on here. But because I have local changes, I can push them. So let's try that. So I'm going to push everything here. And now it's saying, what are you trying to push? And I guess I didn't, like, what we're pushing here is a branch. And there's a default branch, which is called master in this case. So the way it works is that all your code goes into a branch, and eventually you can have more branches. I'm going to talk about that in a bit, but for now, just assume that this like main line of commits is your main branch. Back in the day, everybody called their branches master because it was the main branch. Now it's not PC to call it master. You're supposed to call it main. So a lot of repos will change it from master to main. It really depends what interface you're working in. But you're probably going to see more main than master at this point. So I just renamed mine. And then you see how easy it was? I just right-clicked on this, hit rename, and it renamed it. This is the kind of thing that people who use the command line don't know how to do and never bother doing, because who knows what the command is. So that's kind of where using a GUI is really easy, because you have access to all these features. All right, so now I'm just going to push. And it's saying, where do you want to push this to? I want to push this to origin. And then on origin, it's going to be called origin/main, which is the name of the remote / the name of the branch. And if you look in the interface, it added a little icon here. So there's this main tag here, which is my local thing. And then this little icon is a little cat, which is the GitHub cat. And all this says is that, okay, the remote is at the same commit level as you are. And that's why these two icons are here. So if I go back locally here and I changed one of my files and make a new commit. So for example, I just remove this thing here. I have a new local change, stage. Let's say remove unused header. So now you can see in my tree that the remote only has commits up to here. This extra commit is what I have locally on my computer, and you can see that they're out of sync. But they're still in the same tree, so the good news is all I need to do is push, and they'll be back in sync. If Origin had different changes that this one didn't have, then we might have a bit of a problem. But for now, we're fine. There's the same thing happening here in the branches section. You'll see that the main one has a little 1 and an up arrow, which means you have one commit that hasn't been pushed yet. There's a lot of things that kind of like indicate that your local and your remote aren't in sync. So let's do, what's next? Let's see. Okay, so merging. So let's just go back here. So let's say instead of just one repo, we had 2 people working on this at the same time. So I'm just going to duplicate this folder. Whoops, that's not the button for duplicate. No. So let's say ONX other is one of you working on your computer, and you have your own copy of this Git project. What do you mean? On your own computer?
Yeah.
Yeah, so you would never do this on your own computer, because there's this idea of branches means that you can have different versions of your project at the same time. So it makes a lot more sense to work in the same repository and have different branches than to have like multiple copies of the folder. So yes, so usually you'll have only one repo on your computer. In this case, let's assume that this is a different computer somewhere else in the world. So now I have
Sorry, could you repeat the question? Since I can't hear the.
Yeah, Alexander was saying usually you won't want to have multiple projects, like copies of the project on your same machine. And that's true because usually, I'll show you this in a second, but what you can do is in one main project, you can have different versions of it, which are called branches, and you can kind of swap back and forth between them. So that's a lot easier to do than to like duplicate the entire project, the entire Git history twice on your computer if you want to try something different. Exactly. It defeats the purpose of the ledger. Does that make sense?
Yes, thank you.
Cool. Okay, so now let's say we have two different people working on this. Let's say ONX other decides that they're going to make some changes. Oh, wait, actually, before we do that, I'm going to delete this. How do I do that? Just give me a second. And delete. Don't worry about what I'm doing. Okay, so let's say before I made this change, someone else came and like cloned the project from GitHub, and this is what they have. So in their version of the project, they only have all the changes that are pushed to GitHub. In my version, I have this extra change. Now, let's say on top of that, they go in and they make a change. So they'll go in the ingredients file and say, oh, we also need cilantro, and we also need salt. Okay. So their version of the repository, oh shit, I did the wrong one. Hold on. Open that up. This is gonna get so confusing. Yes. Okay, here's the second project. So this second person says that we need cilantro and salt. So if you go back in Git fork, the first person doesn't see any changes. Their local changes thing is empty, but the second person has these new changes that they have to push. So we'll say, add more ingredients. Someone's going to commit and push. So now, if we look at all our commits on the second person, person B, they've got this extra add more ingredients commit here that they added. Now, if we go back to ONX stuff, they don't have that yet. But if I, let's say I want to pull, which means I'm like, okay, I'm ready to like, actually, no, let's say I want to push. I'll be like, okay, I made a new change. I want to push it up. So then I'll hit push, and then I'll get an error. And the thing with Git is you're going to get a lot of errors, and you shouldn't worry about it. What you need to do is read the error, because it'll tell you what's going on. And then what's it saying? What is it saying is that updates were rejected because the remote contains work that you do not have locally. That's pretty clear. So you're like, oh shit, there's some work that I need. So there's two things you can do. You can try to pull, and pull will basically say, okay, I'm going to try to get the changes in, and I'm going to automatically try to smash everything together and merge it, which usually works. But sometimes you want to kind of see what's on the server first and see if pulling is a good idea, or if you need to like have a conversation with the other person, or maybe plan a little bit for it. So that's what fetch does. So what fetch will do is it'll just update and get the changes from the remote, but not actually add them to your branch, or not actually make a new commit. So you see that when we fetched, it added this extra branch here, and it's saying, oh, like origin has a new commit that you don't have. And you can actually look at it and see what the changes are. And you can be like, okay, looks like this doesn't really affect what I was doing, because I'm not even working in the same file. So now that I know what's happening on the server and why my push didn't work, I can actually merge these changes. So this is a conflict, but conflict's not a bad word. Conflict just means like two things happen at the same time. So Git resolves conflicts automatically really well. So like I was saying before, what you can do is just pull. And what it'll do is it'll try to pull the changes into main. If it sees that something messed up, it's going to try to fix it. And now you see what happened is that you kind of had a divergence in your branches, but then they came back together, and your things got merged. And usually when this happens and you don't get another error message, it means everything worked out well. And everything is going to work out well, except if both people change the same line in the same file. If you change different lines in the same file, it usually works out. If you change two completely different files, it definitely will work out. So so histories diverge a lot and they come back together a lot, and it's kind of a normal part of the process. I'm going to show you that next. So now what we can see here is that, okay, we fixed this merge, but we only fixed it locally. We didn't actually push this change because the little cat tag is still down here and we're up here. So remember, to put stuff on the server, you push it. So now we can push that up. And it'll kind of like put that remerging back onto the server. So now the server has the merge changes and everything. And here on the other person's computer, if I do the exact same thing, if I'm like, oh, I'm ready to pull, because the merge has already been resolved on the first person's computer, you don't need to remerge on this computer. Like somebody already dealt with it, saved their changes into a new commit, and then you can just pull that without having to worry about resolving anything. So this merge here is actually a commit in itself. It's just a commit that happened automatically. You didn't have to like push and do all that stuff yourself. Does that make sense? Okay. So what was I saying here? If the remote has newer changes that need to be merged in first, the push will fail. This needs to be resolved locally. So yes, like I was saying, first you pull, and then Git will hopefully fix everything. And then once you fixed, you push. Great. And it looks like this. Okay, so we already did the demo, so that's good. But now let's look at conflicts. So if Git can't automatically figure out what to do, then there's going to be a conflict. And the only way to deal with the conflict really is to resolve it by looking at the files and figuring out what to do. So let's pretend that person A and B get on the phone and they're like, hey, like this list doesn't make sense. We need to make changes to it. Like we need to get rid of dough, or I don't know. They both want to do something at the same time. So instead of salt, one person writes sugar. They're like, no, we don't need salt. Let's put sugar. And then the other person says, you're right, we don't need salt. We need potatoes. So they both made changes to the same file. But let's say also this person's like at the same time, they're like, they're saying they are delicious. They also add something to this other file. Both people think they're doing great work, and then they both go and stage their changes. So person one is going to stage both files at the same time, say update ingredients, and add a note, and then they push. They'll push, and then the other person hasn't seen the push yet, but they're like, what, salt? We don't need that. And they make their own change, and I'm like, okay, I'm gonna push, aha. And then we have the exact same situation. It's like, hey, there's changes that you don't have locally. Can you get them? Okay, let me fetch. And then same exact thing is happening. But in this case, if I look at it, I might be like, oh shit, like it looks like we both changed line 7. So let's see what happens. So I'm gonna do a pull. And now, last time when we pulled, we didn't get an error, which means the merge happened with no problem. Now it's saying automatic merge failed, fix the conflicts yourself, and then commit the result. So basically, when we had the issue before, Git automatically merged the files and then committed the result. Now we'll need to do that manually. So this, once again, Git fork does really well. So it'll tell you that you have this conflict, and also you can't really proceed until you fix this conflict. One thing you can do is abort, and what that'll do is it'll say, just kidding, I don't want to pull, and it'll just go back to the state before you pulled. But if you still want to push to that branch, you'll eventually need to deal with this. But let's say you have no idea what you're doing, but person A does, you can just say abort, pick up the phone and say, hey, you deal with this, and then I'll pull when it's done. But in our case, we're going to fix it. So there's a new little icon here on ingredients, which is a warning sign. And then if you click on that file, actually, well, there's 2 files. So remember, we changed the README and we changed the ingredients file. The README is already staged because this one had no conflict. So it's like, this one's ready to go. This is the one with a problem. So what are you going to do about this? So you can hit this merge button. Well, wait, hold on. No, my screen's too little. Cancel. So one thing you can do is if you say, you know what, like person A was right, I don't need to add salt, we'll stick to potatoes. If that happens, you can just say, okay, forget my change, I'm just going to use their change. And then if you just do this and you click this button, it'll undo your changes and only keep their changes. If it's the opposite, if you're like, no, I was right, they were wrong, I want to delete their changes, then you just click uncheck that box and check this box, and that'll get rid of their changes and just keep yours. But let's say you want to keep both changes, or you want to write something else completely. So then you can hit this merge button, and this will show you exactly where the issue is. So this one is saying that there's a conflict at line 7. Like everything is fine until cilantro, then one of you added potatoes, one of you added sugar. So what do you want to do? So you can either say, oh, you know what, they were right, I'm just going to do potatoes. And if you do that, if you click here on, if you click on select left, you'll look at the bottom. The bottom is the result here. It'll say, okay, there's no more problem. And now after cilantro, we have potatoes. Let's say you want to pick sugar. You can say select right. And then after cilantro, we have sugar and we don't have a conflict anymore. So we can just hit resolve and we're done. Let's say you want to keep both. You can actually say select left and select right, and it'll just add them one after the other. So let's say you do want both ingredients. You can say, you can just click both things and then it'll say, okay, we'll put one, then we'll put the other. And then that also resolves the conflict. And finally, if you just want to do something completely different, if you're like, you know what, fuck it, let's get sugar potatoes together. So let's just have sweet potatoes as our entry. Then you can just go down here and type the result, and then you can resolve it that way. So there's many different ways to resolve it, but really what you need to do is look at the file and then figure out, like, am I keeping only your changes? Am I keeping only my changes? Am I keeping both? Or am I doing something completely different? Once you're done, you'll hit resolve. Now, at this point, we've resolved the conflict, but we still need to commit what we've done. So it's telling you at the top that all conflicts are fixed. You can still go back and abort if you're like, oh, maybe I shouldn't have done that. And like, that'll just revert everything. But if you're happy, your changes are staged, you already even have a commit message ready to go that says that you merge this branch into this branch. So all you need to do is commit that. And then if you go here, you'll basically have a message that says, hey, we merged these two branches. By the way, there was a conflict, but it was resolved. And if you're happy with everything that's just happened, you can push to the server. And if I go back to person A, if they pull, they won't have to deal with any of these issues because they've already been dealt with. So when they pull, there's no problems. Everything just works. Make sense? Okay. So don't worry about conflicts. They happen. The only time they are annoying is when you use files that you can't open. So everything so far has been text files, which is easy. If you have a conflict in an image file, like in a JPEG, you can't really go and say, oh, I actually want to keep like these pixels and throw out these pixels. It's kind of one or the other. So that's where it gets a little bit trickier. But usually with code, text files, Unity projects are all text. So all that kind of stuff, you can totally like just go in and fix yourself. Okay, I just didn't need any of these icons because I just did all this. Sure. I have a bite of pizza. If you just go on Google Images and type get memes, like all this crap shows up. Pretty good.
There's the Reddit subreddit programmer humor is also very fantastic for some of these.
Well, now you'll understand all the jokes, man. Here,
And to like
kind of just laughing.
being a forest.
Yeah, exactly. We've kind of seen this already, but all the commits that are in a row are part of a branch, and you can have many different branches. When two people make changes at the same time, there's automatically going to be two different branches that get created, and then they'll eventually merge back into the same branch. So that's what we've been seeing here. So here we had two different commits from two different people. So you can see there's a dot here for this one, a dot here for this one. Then they both came back into main. This happened again with a change here. So things will branch out and branch back in whenever two people work at the same time, kind of naturally. But also, like I was saying before, you can create branches yourself if you want to have a different version of your code. So the reason why that would happen is, let's say you want to test out a feature and you're not sure you're going to keep it. You're not sure it's going to break anything for anybody else. what you could do is create a branch, work in it, and then if you're happy with it, you can either push it back in the main if you want everybody to use it. If you're happy with it, but you want to keep it separate, you can just keep it separate forever. If you're not happy with it, you can throw it out and then make it disappear. So there's a lot of things you can do with branches.
Is there a way to, in some way, let's say like working on a project with somebody and there's like one text file, JSON file messing with, to indicate that you checked it out or that you're actively working on it, cross fork, or you have like even like you just text, you have like a different messaging system. They're like, hey, I've checked something out that's important or something like that.
Sure. I'll repeat for Zoom. So Matthew asked, is there a way to kind of inform the system or inform the other user that you're working on a file? So let's say Matthew is working on the README file. Is there a way he can lock it and like make it so that I can touch it, or that at least make me aware that he's working on it? Yes and no. So in usual Git, where you work with text, no, because the way the system is intended is that you're supposed to all work in the same file and smash things together, and it's supposed to work. Because usually you're not working on the exact same thing in the exact same file. However, there's this this other thing called Git LFS, which I'm going to talk about in a bit, which is used for binary files, so like images and things that you can't really merge, which has locking support. And what that means is if your server supports it, you can actually lock a file, and then that'll inform everybody else who's connected to that remote that that file is locked and being worked on by somebody, and nobody else can work on it until you unlock it. So I think that's something that's very common in Perforce or in system. In Unreal, you kind of have to do that because you can't work in the same file at all as someone else. So it's part of it, but it's not really part of the Git way of life, you know? Okay, so back to branches. So let's say you make a new branch, you work in it, it'll look something like this. In Git, let's say person one wants to make a new branch. You basically click the branch button up here. It'll say, what do you want to call it? You can call it whatever you want. One convention, which I like, is that you kind of say what it is or who you are. So I'll say Elie, and then you put a slash or a dash or whatever, and then you give it a name. Like, what am I going to do? So I'm going to call this branch Elie. I don't know, what else am I going to do here? Computers. This is the branch where I'm going to make a file and list all the computers I own. Okay, so now after I've done this, because you'll see here that now there's this new Elie computers branch that appears in my tree. It's highlighted, it's in bold because that's the one that's currently active. It's also highlighted in bold here, which means that's the one that's active. And this is a list of all my branches. And because I did this like Elie slash thing, Git fork does this extra feature in the GUI where it like makes a little folder and allows you to put stuff in there. So if Elie wanted to create a different branch, I could call it Elie slash something else, and it would go in this folder, and I could kind of like keep my stuff organized. So usually when I work with a bunch of people, we do something like that where I say, okay, everybody just like call it your name slash whatever, work in there. And then that way, if I don't want to see your stuff, I can just hide it and I don't have to worry about what you're doing. Completely optional, but very useful. Okay, so now I'm going to work in computers. Actually, before I work in computers, so that's how you do that. One thing with a branch, just like the main branch, is it can stay local, or you can push it to remote, or you can push it to 2 remotes, or you can push it to 3 remotes, or only 1 remote and not the other one. So it's just kind of like everything else. You can choose where that branch lives. The branch doesn't have to live on every single instance of this repository, every single fork of it. So for example, let's say, actually, I'm going to give you a real life example. I'm working on a project called Forager, which needs its own special version of Unreal Engine. So that sucks, but that's life. So basically, Unreal Engine is on GitHub, and they have their own GitHub repo, their own GitHub page, their own, like, everything is exactly the way you'd expect. What's this? Oh yeah, right. So if I go to github.com/epicgames/Unreal Engine, I see the exact same thing I was seeing on my own personal GitHub. There's just like code and files, and if I click this and click this, I can grab the project and pull it down to my local repository, which is what I've done. But now, the reason why we have to build for source is because there's a bug in 5.1 that we had to fix. But I don't have the rights to push stuff to Epic Games because I don't work for Epic Games. And also maybe the way I fix it is not the way they fix it. So what happened is I created my own branch called 5.1 Forager. And that's the branch I was working in where I fixed my bug. That's the branch that our project builds against. And then if you go to, where is it? What did I say I called it? Oh yeah, 5.1 Forager. So if you look at my list of branches, I have all the branches from Epic Games, and I also have my own branch. So my local repository has all branches from Epic Games and from Forager. The Epic Games repo only has the branches from Epic Games, and they don't have this one special branch here. And if you look at it here in the tree, you'll see that it's like a lonely thing where that doesn't really go anywhere. And we haven't updated this since March, but then you can see that Epic made a bazillion changes and a bazillion branches after us. So one thing that's cool with a branch is if you want to like keep a specific version of something and make sure that it doesn't get updated, you can kind of branch off of main and say, okay, I'm going to call this branch Forager. I know this is the Unreal Engine version that like builds for Forager. So even if I go back to this in 10 years, I know I can rebuild Unreal Engine for Forager if I don't touch anything. In our case, what we also did is because we wanted to make sure that this was backed up, on my GitHub, I have an Unreal Engine fork. So I basically Unreal Engine lives on two remotes. It lives on Origin, which is my own repo. So it's on a company called Forager Troop, which is the one we work on. And then I have Upstream, which is the Epic Games one. So I only read from Upstream, and then I read and write to Origin. It's not that big because it's all code. So it's all text files, so it's pretty manageable. But once you download it, if you want to build Unreal Engine, you have to like click this special script, which downloads a bunch of binaries, and then it gets massive. And then when you build a project, it becomes 100 gigs. But the repository itself, like without all of that extra stuff in it, is probably like a couple of gigs, maybe. So it's not too bad.
You are allowed to take a 5-minute pizza break if you want to go.
Okay, let me finish on branches and then I'll do that. So, yes, like I said, branches can live only locally or they can live on a remote repository, and the same rules apply. Like, if I decide to push my branch on a remote, then as long as every time I want to keep pushing to that branch on the remote, the histories have to match. So if somebody else starts pushing to it, then I'll need to pull in their changes, merge them in, and then push that back up if I want to keep working on that branch. So if you work with other people, it's all the exact same rules. And then if you haven't made changes to the same file, the merge will happen automatically. It'll be easy. If you have, then you'll have a conflict and you'll have to deal with it manually. So that kind of process just happens every step of the way. Everything has to be in sync all the time. That's just the name of the game. And then another thing that's cool with branches is that you can merge back into the parent if you want to. So you can keep them separate and just kind of like run your own course. Or if you're testing out a feature or you're testing out something and you're happy with it and you want everybody to use it, you can merge back into the main branch. So yeah, so there's like things you should do to not break everything, but let's say we go back here. So person one is working in this new computer branch. So I'm gonna go back to person one's file. I'm gonna make a new file called computers.txt. I'm gonna say this Dell laptop, and I also have like a big PC thing and a little laptop. And then I have my list of computers. And then I come back here, same thing, stage. I say Elie loves computers. Okay, and now if you look here, the branch Elie computers has a new commit. The branch main hasn't changed at all. Both the local version, which is this little node, and the remote version, which is this guy here, because I'm working in a completely different tree. If I go here to ONX other and I fetch to get the newest changes, nothing's changing because this new branch is only local. I haven't really done anything to it. If I push it, it'll say, okay, do you want me to make a new branch called Origin Elie Computers? I'll say, sure, do it. And now it gets a little GitHub icon as well. Now if I come here and I pull, I get the new reference, but it doesn't change where I am because I'm not on that branch. So I can still see that there's progress being made, that there's stuff happening, but it doesn't affect my work because that's not the branch that I'm on. I'm on main, and the other person is on Elie computers. Okay. Now let's say here, person 2 in main says, "Oh, I know we said sweet potatoes, but what about like regular potatoes?" And then they say stage, let's say don't forget the regular potatoes. And then I push that. So now if I look back at my tree, there's 2 different commits that happened. One is on main, one is on Elie computers. If I come back here, the exact same thing that just happened will happen. So if I say pull, I'll just see that there's a change, but it won't affect where I currently am. So this thing of context switching. So I'm currently on a branch called Elie computers. If I'm like, okay, that's fun, but I really need to go back to main and finish that list, I can just double click here and it's going to change my current repository to match that commit. So now if I go back to look at my files, computers doesn't exist anymore. I mean, well, it does because it's open. I swear. Well, actually, no, yeah, you see it's like, no, this thing doesn't exist anymore and it's not part of my folder. If I go back to computers and go back here, now it's back. If I go back here, I'm in this state. So I can basically switch really quickly between both branches and it'll basically update my files. It'll change my files to be at whatever version they're supposed to be at. Branching is super lightweight in Git. And also commits are really lightweight in Git because it doesn't push an entirely new version of the files. It just pushes delta. So whatever changes there are is what it pushes and what it saves. So you can make as many branches as you want. There's really like no limit there, and it's encouraged to make a lot of branches to try things and then just merge them when you're ready. So don't worry about like space or anything like that when you're branching. So let's say all this happened and now I want to merge these changes. So if I into main, so how would I do that? I want to merge everything back into main. My main is not up to date with the origins main, and also I have this extra branch that I want to merge in. So what should I do? How would you do this? Let's do it. Let's switch it up. How do I merge all my changes into one?
You want to merge your computer's branch.
Yeah.
You merge it locally.
Okay, so I'll go to my local branch and then I'll merge computers.
Right.
Yeah, I can right click on it and then click merge, and that'll merge it. Basically, I can right click on anything and hit merge, and it'll merge into whatever is bold, which is the one you're on. So one option is to right click on this and merge it into main. However, we're still kind of diverging here because there was a change in main on the server that we didn't pull yet. So now we'll have to do a second merge and merge that into main to bring it back to where I am. So, and that's totally fine. Like that's just the way to do it. But you're basically doing 2 merges. Another option is
You're merging it into your local main.
hey, what's happening here? Okay, where do you think the button is? I think it's here. Okay, I don't know. Okay, here we go. Now, if we backtrack, another option is we just pull, which will get the changes from main. And now my main and the main that's on the remote are together, and then I merge into it. Both are fine. Just ignore that. That's because I reset my stuff. Pretend that's not there. Okay. So then what I would do here is I would say, okay, merge that into main. What is up with this thing? And that basically makes a new commit that says, okay, I merged Elie computers into the current branch. Right, and now that's still only local. So then if I push that, now my main will have everything. and Elie Computers is still there. So if I wanted to do more work on Elie Computers, I could, and that would branch out and do more work there, and I could merge it back in if I wanted to, or I could just keep it separate. And that's kind of how you do branching stuff. Do I have?
That's even between the opposite too, on the branch for you.
Yeah, that's very true. So sometimes you'll work in a branch and then you'll see a lot of stuff getting committed to main or to like a branch that you're supposed to be like updating with. And you're like, oh shit, like I'm really diverging from the main thing, but I'm not ready to push my changes in yet because they're broken. So what you can do is you can merge main into Elie Computers or merge main into whatever you're working in. And then you're still like pulling in the changes as you work. And then when you're ready to push back in, it's not like you wrote a whole book and now you're trying to like smash into this other book. It's just like you already have tidbits of the other book and you can bring that, you're bringing it in together. All right, let's do a pizza break. I mean, to go back to like, I don't think Unreal Engine is a good, I mean, it's a pretty good like example, but look at all the people working on this thing at the same time. And the thing mostly runs, like it's not really broken. Another good one is like open frameworks. You can see like a lot of people just pushing, and if you notice, I'm good for now, thank you. There's only 2 branches or 1 branch really. And everybody just like stacks changes on top of the main changes. And because it's all text files, it just totally works. So it's really like, it's, you know, those are like testaments that the system works when you use it properly. All right. So that's kind of like everything that I've showed you so far is the most important stuff. That's also the basics, and now everything else is kind of extra and super useful and good to know. So, all right, do you want me to, I can wait for you. Do you want me to wait? Yeah, why not?
What time?
You're leaving right now, and like, because I can jump to Syncthing quickly, if that's what you want to see.
In about 10 minutes.
Okay, yeah, we can just go to Syncthing to change it up a bit.
I honestly watched that.
Oh, okay, well then it's, yeah, then maybe I'll just stay in order now. Look, yeah, through the magic of editing, we'll take the Syncthing part and put it at the end.
You use it in place of something like GitLS, the same thing, or is it more like that?
Both. It like depends on the project, but I've used it in both cases. Yeah. For Forager again, like all of our mushroom sequences are just massive. And they're just like sequences of OBJs, and every sequence is about 5 gigs. So we basically have a folder in the Unreal project directory that's just has like a dummy file in it, and that's where the folder where the sequences go, and that's what's synced with Syncthing. So all the files come in from Syncthing, those heavy files, and then everything else comes in from Git. Yeah, that's a great way to do it too. All right, so what are we talking about here? Tags. Okay, so remember I was saying before, like when you want to bookmark a commit, you could use a branch and then make a new branch and give it a name. There's actually a thing in Git that's made for specifically that, where you can tag a specific commit. So you don't have to make a new branch to tag something. You don't have to like do anything special. You can basically pick any commit in your project and add a tag to it, and that tag is basically like a reference point to that thing. So if you in Git fork, if you right click on anything, you write new tag, and the tag can be anything you want. It's just a name. Like I can say like Git list here is the name of this tag, and now I have created this tag here. And like everything else, it's only local until I push it. So I can right click on that tag again and say push good list to origin, and then the tag is going to go live on my GitHub server as well. Nope. If you have Actually, if you'll get an error if you're trying to use the same tag twice, but you can just delete a tag and create a new tag instead or something like that. So it's not really a fixable conflict. You just have to like pick a different name. And that's it. And those are obviously super lightweight, but it's a really great way to like kind of tag progress or tag specific versions of things. I use that a lot when I release software. So for example, this project is called Collection Score. It's this project that I'm doing at the Museum of Natural History. It's full of bugs, but I can only create an update every week. So basically every time I send them a version, I make sure to tag it so that I know what I sent them. And then it has a version number. So every one of these purple things is every time I send them a new version. And this is actually auto tagged. So that's something I want to show you later. Like, I'm not going to show you how to do it, but you can like add these like automatic steps in GitHub where you say, okay, this is a good one. And then whenever you create a good one, it does something automatically.
You never remerge the context tabs?
No, because it didn't work. Or I think it wasn't like, it was just like, this kind of works, but it's not really going anywhere. So I just left it out. But see, all these tags are different versions of the software that was released. So that's a great use for them. Easy peasy. Okay, a stash is a temporary local commit. So if you're not ready to commit something to like your general ledger, your official ledger, but you have working files and you need to kind of put them away for a little bit, you can kind of save them into a thing called a stash, and it'll save everything and then clean your local copy so that it's back to the state before the stash. And then you can kind of do whatever work you had to do and then go back to it. I think that makes no sense until I give you an example. So
I would do a stash as opposed to just like leaving out a brand for yourself or something like that.
because sometimes you're just, it's very temporary. It's like you're in the middle of working and like, let's say you're in the middle of working and somebody else fixed the bug that you need. You don't want to commit all your stuff and make a new branch and do all that, but you want to pull their changes. You're like, okay, I'm just going to stash my changes, pull your stuff, and then bring my changes back. So that pizza was all right. Let's say.
Like, this is over. This is over.
Okay, so I staged that. Comments on the, oh wait, no, so I don't even do anything. I'm not committing that. Oops. Okay, so I have this change here, then person two, they go in and they add a new ingredient, which is tomatoes. Did I already put tomatoes? More tomatoes. Okay. So they go here. Oh, they didn't pull. What are they going to do? So there's two things you can do. So here's a situation where I made a change and I'm ready to push it. And I'm like, shit, like someone else made a change before me. What do I do? So one option is you just like say, whatever, let's see what happens. And then you pull. And if there was a change in the file that you changed, that's going to tell you, hey, you can't do that. Like deal with your file first. Okay, so because there was no changes in ingredients, when I pulled, it was fine. So now I can actually go back here and I can push my ingredients file and say more tomatoes and push that. Now let's say this person here, I'm actually going to go and change ingredients as well here. Actually, what I'm going to do is nobody knows what a cuke is. It's a cucumber. Yeah, so now I changed this to cucumbers and now I want to do the exact same thing. I'm like, okay, first let's see if there's changes. Like, oh, I have these two changes I need to make, but I don't have the latest update. Let's try it and see if it works. So I'm going to pull. And it's going to do this. And I'm going to pull. Oh, it worked. Okay, that's cool. Sometimes it doesn't work. Wait, where did I make that change? That's cool. Okay, let's assume that it didn't work or whatever. Or let's assume I don't want to do that. Let's say I want to I don't want to take any chances. I just want to pull the changes and then I want to put my changes back on top of them when I'm done. So what you would do is you would stash it. You can put a message in for your stash. You don't need to. And then what that does is it creates a new, it's not a commit, it's like a stash. It's like basically all those files you had, they got saved temporarily locally. And now your working copy is clean again. So if there was something I have to pull from the server, I could pull it now. And I know that it would come in cleanly because my local repository is clean. And then after I've pulled them in, I can reapply my stash. So I can either right click here and do apply stash, or right click here and do apply stash. You have the option to delete the stash if you've applied it and nothing broke, or to keep it for later if you need to. I usually will just delete them. And now what happened is the stash disappeared and I have my changes back. So think of it as like saving things on the side in a temporary branch. That's what a stash is. You can't push a stash. It's like really just a local thing. But super useful when you're merging to like put stuff to the side. I just did that. And ignore list. Okay, so that's what you're talking about. So remember I was saying that every single thing in that project folder gets tracked by Git. Sometimes you don't want that. Sometimes there's files that have private information like passwords that you don't want to put on a repository. Sometimes you have build files in your project. For example, Unity, whenever you open the project in Unity, it creates all these temporary files that are specific to your computer, and also they're just going to be generated over and over again. So there's no reason to push those to a repo because they're just going to be files that change constantly that have no effect on the project and don't do anything. So those can be ignored. The way you ignore files is you add a .git ignore file, which is just a text file in your repository. And then on every line, you list either a file or a pattern. So in this case, these two brackets mean one or the other. So anything that's like /library will get ignored, whether it's a capital L or lowercase l, so on and so forth. This specific file, project settings, Unity Connect settings.asset is going to get ignored. Anything that's in your VS or VS Code folder. So all this is temporary stuff that either Unity or Visual Studio Code creates that you don't really want in your project. Now you're probably wondering, well, how do I know what I need to keep and not keep? What am I supposed to do? Well, someone else thought about this already. Yeah, talk to your developer, and what your developer is going to do is go to this web page. GitHub has a repository of a bunch of git ignore files for a bunch of different platforms. So you can kind of go on here and find the one you want. So let's say we're doing a Unity project. I'm going to scroll down to the use. Unity.gitignore, and I can use this as my starting point. So the way I would do this is I would just copy the file. Then I would go in my repository, which is here, and I would create a new file. And you have to call it .gitignore. You can't call it anything else. And then I would just paste the contents in here. So if you put it on the first level, it's going to do everything from that level inwards. If you put it as a level in, it's only going to affect that level in and whatever's in there. So you can even have many git ignores that like cascade. So you can have one that's a top level one, but if there's a folder that's ignored but has an exception, you can put a git ignore in there. That's an exception.
The one you just downloaded is definitely, those are made for the root.
Yeah, those are made for the root. And so usually what I do is I get a starting point, which is this. And then if you want to add more stuff to it after, let's say I create a new file called potatoes to do whatever. So now if I look here, whoops, in my repo, first of all, this gitignore file is just a regular text file. It's treated like any other file. So if I want to keep it, I can just stage it and then commit it. So say add gitignore file. And if I want to, and now nothing that's in here is in the gitignore file, so it doesn't matter. If I do want to edit it, I can actually go open the file and type in the thing I want to change by hand. Or if you use a GUI like git fork, you can right click on a file and say ignore. And then you can say either ignore the file itself or ignore a custom pattern. So if I just say ignore potatoes, you see what happened is that potato file disappeared from my staged list. And the gitignore changed though, and the gitignore now has a new line in it, which is potatoes to do. Let's say I don't want to, I want to discard this change. I want to go back to what I had before. Did it delete my file? No way. No, yeah. So now potatoes to do is back. Nothing's changed. Let's say I go to ignore and I do custom pattern. Then I can type in what my pattern is. So let's say the pattern is anything that starts with potatoes. I don't want to see. So I say potato star, and then it tells me, okay, well, you're going to ignore potatoes to do. Is that what you want? Let's say I say R star. There's nothing in there. And that's because README is already tracked. Like if there was a file that wasn't tracked, Oh, wait, that's not true. Wait, R star. Oh, sorry, forget what I just said. It's because I didn't put a star. So if I do R star, it's going to say, oh, you want to get rid of README. But no, I want to do potato star. Anything with potato, I don't want to keep. And now if I go to the get ignore, it has this, just, it's pretty simple. It's just an extra line at the bottom. And that gets ignored. Okay. What else we got? Yeah. So we already kind of saw this and I mentioned it, but for text files, Git is amazing because it can track different changes in the file. Partial changes are trackable. Diffs are easy to merge. Everything is like lightweight. For binary files, it's a bit more of a pain in the butt because it doesn't do any of that stuff. It'll basically replace the entire file. It doesn't know how to merge it. It doesn't know how to compare it or do anything. And you'll see that's also how your repository gets really big really fast is every time you make a change to a binary file, it'll just like upload a brand new version of it. So there is a sort of solution to that, which is called LFS. LFS stands for large file storage. And it's just an extension to Git. So it's not part of Git, it's just this extra thing. And what it does is it basically sets up a server where it stores all these binary files. And then in Git, instead of putting that file in, it'll create a small text file that just has the ID of that file on the server. So it says, okay, like whenever you see this file, which basically is just this text file with this long number in it, grab that ID, go on the server, fetch the actual binary file and download it instead of this text file. And it does all this under the hood behind the scenes, so you don't need to worry about it. A lot of these hosting services like GitLab, GitHub, Amazon, all that, they have this set up. They already have the server set up. If you want to complicate your life or do something custom, you can make your own server and set that all up yourself, but you don't really need to. So this is super useful because your Git repository stays lean and all the files in there are text files and any binary files get stored somewhere else offsite, kind of where they just get downloaded in automatically. And how do you tell Git what files you want to go in LFS? Use a .git attributes file. So it's the same idea as .git ignore. You just basically add entries one per line with a pattern, and then whenever it sees that, it says, oh, if you match that pattern, you're an LFS file, and I'm going to convert you to that weird hash format and upload you somewhere else. The thing about it that's weird is that you don't just put in the pattern, you also put in all this garbage after. I don't know what it means, but you just have to add it at the end. So just do it that way. And then if you know what it does, let me know. If you don't, it really doesn't matter. I've never had to worry about that. And same thing as with the git ignore file, somebody made a repo that has very common Git attributes patterns. So let's say, once again, I'm doing something in Unity. Does it have a Unity one? It does. So you'll see that it says, okay, the binary files are actually the ones that are binary are going to be these ones down here. Don't worry about this stuff. It's just somebody being fancy, but anything that's a Unity package, a cube map, any 3D model file like an FBX or a DAE or whatever, an STL, any audio file, video file, image file, zip file, blah, blah, blah. All these things, it basically identifies them as binary files, and those will be stored offsite, not in the Git repo. And then same as the other thing. So you could just copy that, go in your repo, add a new file called .git attributes. Whoop. And as long as you have that file in there, it'll know what to do with it. I don't know if you can. I don't think you can right click on a file and say this is an LFS file. I think you have to actually go and edit that file manually in Git fork. So if, for example, you have your own 3D format that's not part of the list that you want to add, you'd have to actually go edit that file manually and copy a different line and change the extension. Okay, cool. See ya. All right, and that's kind of everything that I want. That's like, I guess, the theoretical part of Git that I wanted to talk about. Then the next few slides are more about like workflow. And the main thing with workflow that's important is you have to agree with the people you're working with, and you have to agree with yourself. And you have to be consistent, I think, is a big thing. So one thing that you really want to do is have a good branching strategy. And that just means that you just have a plan and you stick to it regarding how you branch things and when you merge things back into main. So what a lot of people do is they'll have one branch that always builds and always like has no errors in it. And you'll call that one main or stable. That means that anybody who downloads your project, if they download main or stable, that project is going to build on their system. It's never going to have a broken piece of code in it. So that means that whenever you're working on something, you would do that in a different branch, test it. When you know that it's working, you bring it back in. And then one way of working is you have like a second main branch, which you call develop or unstable or whatever. And that's the one that you would merge your features in to do all that testing that I'm talking about. So that's the one that would get stuff in from main as it comes in and get stuff in from the features as they come in. And if that one builds, then you can merge that back into main because you know that all that stuff is going to build and be fine. And then kind of like what I showed you before, whenever you work on something, you create a new branch for it, which can be your name, fix, feature, whatever, like verb you want, whatever word you want. You just kind of figure out a naming convention you like and you stick to it. And the more you stick to this, the less problems you'll have down the line, because when you look at your repo, you'll be like, okay, I know this branch might not build. I know this one probably builds. I know this one definitely builds. And it's very easy to know what's going on. Yeah, and then the last thing on this slide is you don't want to stay in your feature branch too long without merging from main or without like talking to anybody else, because that means that you'll diverge more and more from the main trunk that everyone's working on, and that's just, you know, asking for conflicts. So that's not something you want to do. We don't need to do a demo for that. And then the last thing is good commit messages. Well, good commits in general. So I've been saying since the beginning, commit small, try not to combine changes, like keep features separate and commit features one at a time. Commit often, don't like work all day and then commit once at the end of the day with like a big fat thing that just has all your code in it. And commit meaning, make sure that the messages that you write have a meaning. That way, when you look at your history, you can actually understand what each commit did. It's not just ASDF or a bunch of garbage that doesn't mean anything. And that happens so commonly, it's kind of crazy. Every project I work on, there's always one person who can't be bothered to write good commit messages and commits giant things. And it's just like, it's fine when it's fine. And then when something breaks, that's the commit I'm going to revert. And that's the work that's going to have to be redone because we don't know what's going on. It was especially a nightmare with Forager because Unreal is only binary files. So you can't actually go in and see what's going on. So you're really relying on your commit messages to know what each commit does. Otherwise, it's just like a bunch of gibberish. And by doing this, you can rewrite history in many ways. So if you're still on your local branch, which means you haven't pushed your changes anywhere else, you can make amends. So because that work doesn't exist anywhere else, you can still manipulate the tree. You can like go and change commits, delete commits, move one. You can actually like swap commits if you want to put one before the other. Those are all things you can do locally before you do any pushing. But as soon as you push, you can't do any of that stuff because whenever you push, you're kind of like you're making your work public and everyone else can see what you're doing. If you do want to change something, what you can do is revert your changes. So let's say I'm going to stage all this. Don't do what I'm doing now, but I'm going to do it.
You can share all those slides.
Don't do this. Yeah, I can do that. Okay, so let's say I look at this again and I'm like, more tomatoes, like why did we add more tomatoes? We already had tomatoes on the list. But I already made this commit and I already pushed it. So I can't really go and delete that. Because this commit only has this one single change and nothing else in it, there's actually an operation called revert commit in Git. And what that does is it makes a new commit that basically undoes what you did before. So automatically, it created this new commit called revert more tomatoes. And if I go in ingredients, it basically switched back to the version I had before. And this is still part of the main trunk. This is still like legal because I'm not undoing commits. I'm not deleting commits. I'm just adding new commits that undo changes. You can't do this if your commit is 7 files with a bunch of different crap in it. You can only do this. Well, you can, but then you'll also lose changes that you might want to keep. So this is why it's important to work in that way. Another thing you can
reverted back for more tomatoes. It only took out. It's not like it reverted everything leading down to more tomatoes. It's those particular changes.
That single one, yeah. Yeah. So if you made more changes to that line, if more tomatoes, someone else went in and wrote more tomatoes x2 or something on the same line, that wouldn't work. It would be like, hey, someone else made a change first. So you would have to revert the other change, then revert this change.
You
Yeah.
merge the. Yeah.
Yeah, or you go back in time and every time that line has changed, you would revert that until you get to the point you want, which is still easier sometimes than rewriting everything. The other thing you can do when you do that is you can cherry pick commits. So let's say I go back to Elie computers and this branch, I wanted to keep exactly the same, but I really want the get ignore file. And I don't want to deal with all this stuff. So what I can do is I double click here to go back to this branch. If I right click here and do cherry pick, that'll make a copy of this commit into the branch I'm currently in. So it's a completely new commit. It doesn't have the same ID or anything, but the changes in it are exactly the same. That's what a cherry pick is. It's like I'm going to clone or copy a commit into whatever I'm in now. So sometimes yeah, you did a lot of work somewhere and you only want to keep some of the work into a different branch, then that's one way to do it. And once again, you can only do this if you have small commits, because otherwise you're going to be cherry picking maybe a lot more stuff than what you need. So those are all reasons why you should do that. And that's actually how Unreal Engine is built. Like they never really merge anything. What you'll notice is that they just cherry pick. So they have a bunch of branches. They have like a 5.1 development branch or 5. Whatever development branch. They have a 5.1 stable branch. And whenever they make a change and it works in whatever branch, they cherry pick it to different branches. And that's kind of how they work. I don't know why they do that, but that's what they do. So if you look at the history, you'll see exact same commit message, like very close to each other, but on completely different branches. So these two are the same, these two are the same. So you'll have the same commit 3 or 4 times, depending on what work is being done. And maybe like even 4 or 5 times. And I think that's just their way of making sure nobody steps on other people's toes with merging and stuff, but it works. So it's just an option you have. And there's other things here I'm just gonna talk about, but not show too much. So Git has these things called hooks, which means that before or after any action, like pushing, committing, whatever, you can run a script to make it do something. And that can be super useful for many different reasons. For example, what I was showing you before, where whenever I push to my stable branch in this collection score project, it creates a new tag. And it's automatically increments the version number. And that happens automatically. And not only that, it uses all my previous commit messages as a changelog. So there's a file called changelog in this project, which, let me find it here. So this file automatically just lists all the commits per version. So, and it also lists them in categories. What's a bug fix? What's a feature? What's a performance improvement? And what part of what module it's part of, and what commits it references with a link to the commit. And all this is tagged by version. So if you actually open this as a markdown file, you get this really nice version history of what you've done and when you've done it. All this happens automatically for 2 reasons. One is that I have this hook. And the other reason why this happens is because I have a very strict commit message format where every commit message has like a category, a module, and then what I did. And that basically, there's a script that runs that reads through all of these and kind of organizes them and makes a really nice changelog. And that's really useful for me, but also for clients when they want to say like, oh, what did you change this? How come you're charging me so much money? They're like, here you go. That's like the bill. Well, I mean, that's one reason. There's also other reasons. Some hosts like GitHub or some specific people will not allow you to commit code, but they'll allow you to do something called a merge request. And what that means is you'll say, hey, I want you to push my code into your repository, but I know I can't just do that myself. So can you review it? And if it works, can you throw it in? And if we look at think open frameworks will probably have some of those. So this is something that's not really part of Git, but it's part of a lot of these hosting things. So if you go to, they'll have like a pull request section, and basically you'll have your own branch of Git. They'll have their branch of Git, and you'll say, okay, I want to make a pull request here. And then this basically says, okay, like you say, this is what I did. Here are all the commits that are part of my pull request. And then you can automatically do checks, make sure that the thing actually builds. And then there's like a conversation that can be had where people say, oh, why did you do this? Or did you do this or that? And then if it works, they merge it in. So that's a really nice thing to, I mean, it's a little complex, but it's really useful if a lot of people are working on a project to make sure you don't break anything. Similarly, you can have protected branches. So you can say, people can't push to main. They can only merge into main onto your project. And that kind of encourages people to not push stuff straight to main, but to test it first and then merge it in. And continuous integration is basically like doing all this stuff on the fly, kind of like what I showed you with the changelog. So that's Git. Cool. All right. I hope that was useful. All right. It's getting late. So are you guys okay, or are you tired?
Yeah.
Okay. Cool. So the other thing I want to talk about is Syncthing. Syncthing is just another tool that I install all the time on my projects. It's not really like Git, but it's also about sharing. And what you share with Syncthing is files and folders between machines. Think of it like BitTorrent meets Dropbox. It's basically a shared folder that and you can decide who you share it with, how you share it, and all that stuff. It's peer-to-peer, which means that you don't go through the internet. So this is also really useful when you're on machines that aren't on the internet that need to be connected, like on a network. You can still share stuff between them, which is not the case with Dropbox, for example. It's multi-platform. It works on Linux, Mac, Windows, but also Android, Raspberry Pis, whatever you want. Everything has a Syncthing client. It's fast, it's free. And also your folders that you share don't need to all be part of the same like folder structure. You can share one folder that's like C sync. You can share another folder that's like C users, Elie, potatoes. Like you can share many different folders anywhere on your file system. They don't all have to be part of the same architecture. So that's another thing that's really nice with it. And I'm just going to show you what it looks like. So if you are on a Mac or Linux machine or anything else, you would go to syncthing.net and download the actual Syncthing client. And I think there's instructions on how to do it. If you're on Windows, somebody made a package called Synctracer. Sounds pretty cool. And what it is it's Syncthing, but it also adds a little icon in your tray where you can kind of manage it. But everything with Syncthing is managed through a web interface. So essentially what this does is it just opens a tiny browser in a window, which is, which is useful. And it's kind of nice to have that on Windows. So the way you set this up is whenever you install it, it'll give your computer an ID. And then if you want to share your ID with any other computer, all you need to do is go to Actions, Show ID, and they can either scan this QR code or copy this long code here. You just give them that. Then on their end, they just go here to Remote Devices, add remote device, throw in that ID in here, and then you're connected. It's super simple. You don't need to go through a VPN. You don't need to go through, do anything with ports or any shit like that. You don't need to make an account, nothing like that. It's all through these unique IDs. Also, what's cool is if there's other machines on the network that have Syncthing, it'll automatically find them. So in this case, it sees that there's 2 other computers here on the network that have Syncthing, and I'm pretty sure they're your computers that I installed it on whenever I worked on them. So that's that. Once you have a computer that you're sharing with, you don't share everything with that computer, you choose what to share. So to add a folder, it's super simple. You go to add folder, you give it a name, it'll have a weird ID, and then you just find that folder on your computer. So if I want to share my downloads folder, which is probably a very bad idea, I would do this, and then I would say save. Now that's still not synced with anybody, but whoops, let me rename that to something not crazy. So I'll call this downloads. And then the other thing you do is when you go to edit sharing, basically this is a list of all the clients you have already registered with, and then you just check the ones you want to share with. And they'll get an invite that says, hey, you want to share this folder with this person? And you say yes or no or whatever. And it just works. It's super easy. It's really fun. It's really nice. On top of that, let's say that person is sharing way too many things, like me with my downloads folder, and you only want the images in my downloads folder, you can actually go to ignore patterns and say, oh, I only want to receive star JPEGs, or I only want to receive everything except, I want to ignore everything except JPEG. So I would say exclamation mark star JPEG. And that means only download JPEGs, or only upload JPEGs in this case, because the ignore patterns work both ways. Also, if you only want to download and not upload, you can change the folder type to be send only or receive only. So if you want it to only be one way or the other, you can do that. If you're receiving files, but you need to process them before they all get downloaded and you want to receive them in order, in file pull order, you can change this to alphabetic or smaller. You have all these options on how you're sending and receiving stuff. And it all works pretty well. And then finally, because it's a shared folder, that means that if somebody deletes it on their end, it deletes it on your end too. And you might not be comfortable with that. So if that's the case, you can say, if somebody deletes something, it goes into a special like trash can folder on my computer. It doesn't actually get deleted until I do it myself. If the files change, you can do file versioning. So if as soon as the file changes, it'll back up the current version of the file into a special folder and keep the new one. So it kind of does all this stuff automatically for you without you having to worry about it. So it works really well. It's super nice.
Can you do this with just an external hard drive?
Yep.
Yeah.
Yeah, you can use it to do backups. You can use it to do all sorts of things. And then I'll show you an example of what I use it for. I'll show you a few examples, a couple of examples. So this is a project I made called Flood or Human Hatton we talked to. Basically, it was like an architecture model, and it was about like the floods that happened during Hurricane Sandy in Manhattan. And there was 38 screens all around of the structure that each were playing their own independent video. And every once in a while on a timer, the screens would fill up with water and have like this wavy effect to show that they were underwater. Now, to play 38 videos on 38 screens, I just used 38 Raspberry Pis because they're cheap, they play videos well, and we don't like, as long as they're on the internet or on some network together, then I can communicate and I don't have to worry about beefy computers. Because even if I had a computer with a graphics card, I could only probably feed like 4 of these at a time. And the client was cheap also. So what I needed to do, so to sync all of the Raspberry Pis together and make the flood go up, I just networked them all together on a local network. This was at the Venice Biennale. So there was no internet. So everything was just local. But then that was all fine. The only problem was whenever the client was like, hey, I updated this video. Can you install it on 38 computers? I was like, shit, I have to go behind each one of these fucking things and like put in an SD card or USB key and do it. I'm not going to do that. Or if there was a change in the code, I'm like, how am I going to update this project on 38 different Raspberry Pis? So what I did is I had my Raspberry Pi, which was my main device, my master device, which had Syncthing on it. And I had a dev laptop, which was the one I was like, working on as a normal computer. The primary device only pushed changes, it didn't receive changes. And the laptop, same thing, it only pushed changes and didn't receive changes. So the media, which is the videos, I just had one Syncthing folder between everything, and everybody communicated with everybody, which means that if one Raspberry Pi got a file before another one, it could also share it with that other one. So if I had to upload 4 or 5 gigs of videos on these little shitty computers, it happened really quickly because as soon as there was like a kind of like a critical mass where everybody was sharing with everybody else. Yeah. The app itself, whenever I'd make a change to it, I would just put it on the primary device, and then that would go in a special different Syncthing folder where all of the other clients, all 38 computers, were also sharing it. So the app would just update itself automatically on all of the Raspberry Pis as soon as I plugged that one in. And then same with the settings, like every single Raspberry Pi had its own settings, but there was also global settings, like how the mapping was happening. That was also shared on that same Syncthing folder. So essentially I worked on my laptop. When everything was ready, I would put it on this one Raspberry Pi. Then I would go plug that Raspberry Pi into the network, and automatically it would just shoot everything to the 38 computers. So that was like, I think, a very good use case for Syncthing. The other project is, which is the one I mentioned in the email, is called The Last Supper. And this was like basically during Fashion Week, we had to make a music video. We had to shoot, edit, and release a music video made in Unity in about 14 hours, 16 hours. And it was all people in point clouds. We filmed 40 people in point clouds. A lot of them were celebrities. So they were like, we couldn't waste a lot of their time. They were at a dinner. We basically would pull them out, make them do a couple of gestures, record them using Breckle, which is like a point cloud software. And then they would go back, and then we would have to process everything and do all this overnight as fast as possible. This is what the video looks like. So because it's all point clouds and it's like 40 different characters, it was all built in Unity and edited in Unity. So we used Unity Timeline, brought all the clips in. The way we recorded it was we had to do OBJ sequences because that was what captured the fastest. And it's also the format I need to use. All the textures kind of fit on it. Everything was fine. So it's OBJ sequences and image sequences that match them. And we had, I think, 35 guests or something, all doing like little gestures like that. And then everything was ingested into Unity and then sequenced to music, which you can't hear right now for whatever reason. Oh, it's probably playing on the TV, that's why. But it was all sequenced to music. And so we had to do all that pretty quickly. So Unity, if you've used it before, which I think you both have, whenever you start importing massive amounts of files in it, it starts doing this like import loop where it just takes forever to ingest things. And the more stuff you try to put in at the same time, it kind of incrementally gets worse and worse. So it's a total nightmare. So we didn't want to be in a situation with this where we would spend like 4 or 5 of our 14 hours just ingesting content, because that wouldn't leave us enough time to do the edit. So what did we do? So we had a bunch of stations set up. So the capture thing happened at this venue, which was in Williamsburg. So we had 2 computers set up to do captures, which was the ones that had the Connect and Breckle. And those were connected to one computer, which was like the collector converter thing. That computer just got all the footage and prepared it for Unity. One of the ways I prepared it is instead of using OBJs, I converted that to a binary format, and it was like 1/10 of the size. So I did that so that it could be transferred really quickly. And also in Unity, I wrote a thing to import that, and it was importing a lot faster than OBJs as well. So these red things are in one venue, and then the venue had to close at 11, so we couldn't work there all night. So then we had to do all of the editing at a studio somewhere else. So that's where these green things hit. So we had 3 people working on it, all working in the same Unity project, but each working on different things. But that means that every single one of these Unity instances had to have every single character that we had recorded on it. And Unity, we didn't want, like, not only do we not want to spend 4 hours per project doing this, we definitely don't want to spend 4 hours on 3 machines ingesting all this footage. So, and then eventually, once we're done, we need to save all this somewhere. We need to back it up to a cloud server somewhere. So that was kind of like the original idea. So I made 2 Syncthing shared folders, one per capture, and I didn't put them together because I didn't want one computer to like, I didn't want them to conflict. So they basically each were doing their own capture. Both were getting collected into one computer. That computer was running a script that would basically, as soon as new files would come in, it would convert them to this binary format. And then that would shoot everything to the computers at the studio using Syncthing as well. In this case, I used one node because I wanted to use that thing where as soon as one computer gets the files, it shares them with the other ones, and everybody kind of shares with everybody else. So the transfer happens super fast. And then eventually these computers would communicate with Git. So every computer would ingest like 1/3 of the files. And then whenever that stuff had been ingested, they would push it to Git. And then the computers could pull from Git to get the files back. So every computer, every character, every person was only ingested into Unity once. And then the files were downloaded back. Now, the last thing I did is because uploading stuff to Git, just because the upload to the server could be slow, just because GitHub, they like throttle your uploads, and also, usually uploads are much slower than downloads. I ended up setting up a Git server on-prem on the premises. So that way we could like push and pull from Git super quickly without having to worry about getting on the internet. And eventually that local server is what communicated with the cloud server to do a full backup like in the cloud. So I think this is a really nice example of how you can combine both technologies to do like backing up, but also sharing and syncing and really optimizing the workflow so that you don't do anything twice and you don't waste too much time on any steps of the way. So that's that. Ooh, I'm done. Cool. All right.
I really want a copy of these slides.
Okay, sure. I can share them with you.